Okay, so I'm going to start the session. Before that, I'm going to record the session. Okay, hope the screen is visible to everyone. Is the screen visible to everyone? Is the screen is visible to everyone? Is the screen visible to everyone? Is the screen visible to everyone? Okay, is the screen visible to everyone?
Sure.
Okay.
Sir, 1 by x plus 3 plus 1 by x plus 2
Hmm.
और ROC लाई करेगा 3 और 2 के बीच में.
अच्छा, तो काइंडली सेंड योर असाइनमेंट. ठीक है, एक जगह पे लिख दो असाइनमेंट जितना भी है, जितना भी दिया हुआ है, जितना सारा असाइनमेंट है फर्स्ट इंटरनल के बाद, सब असाइनमेंट को एक जगह पे करके मुझे सबमिट करना अलग से. ठीक है.
Okay, sir.
Okay, so in previous class we have studied about how to find out the Laplace transform of the signal, and उसके साथ ही I have given another part of the question is find the ROC. Okay. So ROC, so there is a concept of ROC in Laplace transform also, because ROC is determined in those cases when transformation will be occurred. That means one time scale to another time scale. In Z transform, you have seen that Z transform is the transformation whenever you are going to transform a signal from its time domain to frequency domain. Here in MATLAB also, time domain to S domain you are going to transform Laplace also. Okay, so in this case also we have to maintain a boundation, that is region of convergence, or sometimes it is known as radius of convergence. Whatever you are saying, it is correct, region or radius. Clear? Basically we are saying the region of convergence, that is ROC. So like your Z transform, your Laplace transform also some properties regarding ROC. So we will see what are those properties. So properties of ROC in Laplace transform. Okay. So first of all, property 1. First property is ROC of xs, that means Laplace transform of xt, that is xt Laplace transform, and it will give you xs consist of strips parallel to j omega axis in the S plane. This is the first property. So as per the first property, ROC always consists of strips parallel to your Z omega axis. So first of all, we have to know what do you mean by strips. Can you tell me what do you mean by strips? That is bunch of lines. ठीक है, ये एक साथ, this is strips. Now in ROC, in your Laplace transform, what is the z omega axis? This axis is z omega axis. So ROC will look like this. That is strips, bunch of strips parallel with z omega axis. So this is the first property. Okay. Next property, Z transform में क्या था? ROC will look like this, but in Laplace transform it will look like this. ठीक है? Now properties number 2, like your Z property, Z transform, ROC doesn't contain any poles. This is like your Z transform. Next, property 3. If x of t is of finite duration and is absolutely integrable, that means it can be integrated. Okay, integrable. So roc will be entire s plane. That means if it is integrable, that means suppose x dx from 0 to sorry 0 to n, suppose x of t dx or x of t dt, 0 to n x of t dt. So it is integratable. Okay. So if the x of t is integrable, that means it can be integrated and its duration is finite. Agar ye 0 to n, that is finite duration, then entire s plane will be the ROC. Okay, entire S plane will be the ROC. That means वहां पे Z transform में क्या था? There are condition that is अगर ROC finite हुआ तो ROC अगर तुम्हारा sequence finite हुआ, then ROC will be bounded in between a particular limitation. अगर तुम्हारा x of t तुम्हारा या x of n तुम्हारा infinite हुआ और उसका रेंज 0 टू फाइनाइट और माइनस इनफाइनाइट टू 0 और 0 to infinity, so then ROC will be different and ROC will be of a certain ROC will lie in a certain time limit or certain boundation. ठीक है, but in case of a Laplace transform, if x of t is finite, is of finite duration and it can be integrated. ठीक है, ध्यान से रखना, ये दो डिफरेंस बहुत ही ये इंपॉर्टेंट है. पहला डिफरेंस विद जेड ट्रांसफॉर्म एंड थर्ड डिफरेंस विद जेड ट्रांसफॉर्म, थर्ड प्रॉपर्टी डिफरेंस. दैट इज if x of t is of finite direction, that means it is bounded in a finite duration and it can be integrated, then its ROC will be entire S plane. That is no boundation in ROC. Entire S plane will the ROC of the given sequence or given signal. That is the third property. Property 4. In case of Z transform, we have seen that Z transform in ROC of Z transform also divided into two parts. If x of n is right-handed sequence or if x of n is the left-handed sequence. Similarly, in this case also x of t can be right-handed sequence or left-handed sequence and the ROC will be differed from each other. So, properties 4 says that if x of t is right hand sequence और राइट हैंडेड सिग्नल, ठीक है, दैट इज, इसको हम डिफाइन करेंगे एक्स ऑफ टी इक्वल टू 0 फॉर फॉर ठीक है, राइट हैंडेड सीक्वेंस, देन ये कंडीशन देने की जरूरत नहीं है, इट विल बी मच मोर कंफ्यूजिंग कंडीशन। इफ x of t is right handed sequence, that means right handed sequence, ठीक है, ये राइट हैंड में है, देन ROC equals the maximum real part of any of poles of x of s। दैट मीन्स अगर तुम्हारा राइट हैंड सीक्वेंस रहा तो लाइक व्हेन एवर यू आर फाइंडिंग द पोल्स, सपोज पोल्स, नंबर ऑफ पोल्स आर देयर, A1 A2 A3, ठीक है, सो इन तीनों में से जो मैक्सिमम होगा दैट विल बी इट्स ROC, ठीक है, अगर राइट हैंड रहा। P5 if x of t is left hand signal or left sided sequence, ठीक है, सो ROC equals the minimum real part of any of poles of x of s। दैट मीन्स अगर लेफ्ट हैंड रहा तो जितना भी पोल्स निकलेगा उससे मिनिमम जो है वो अगर लेफ्ट हैंड सिग्नल के लिए और मैक्सिमम है राइट हैंड सिग्नल के लिए। सो दिस इज वेरी मच इजी इन कंपेयर विद द जेड ट्रांसफॉर्म। सो दिस इज द two properties for left hand signal and right hand signal, ठीक है, and the basic difference you have to understand with Z transform। Now last P6, if x of t is both hand signal or both handed signal or both sided signal, then what to do? That just combine both of these. So ROC, let it be maximum is A1 and minimum is A2, let it be. So ROC will lie between A1, sorry, A2, that is the minimum, to maximum, ठीक है। जस्ट रिमेम्बर दिस कि अगर तुम्हारा ROC है तो इसको हम अगर डिफाइन करेंगे जनरलाइज, तो ROC will lie between A max and A min, ठीक है। सो जस्ट लुक एट दिस, जस्ट a minute। Okay, so this is the properties of ROC। Now we are just finding out the ROCs of Z transform, okay, so first of all we have to find out in which direction, okay, in which direction the signal will be situated। So in previous class I have given this equation, okay, so see, in this equation first of all we have to find out the poles, and the poles is e to the power minus t एक signal है and e to the power minus 2t एक signal है. First of all, this signal is left hand side or right hand side? Tell me. This signal is left hand side or right hand side? Anyone, tell me. The signal is left hand signal, right side, left sided signal, or right sided signal? Anyone, tell me. Left hand sided signal or right hand sided signal? Am I audible? Left. Saurabh Kumar is saying that left hand sided signal. Is it? So see in which direction the signal will be directed. Okay, I am just taking out the signal. Okay, this is the signal example, and I have to find out its ROC. ओके, सो देखो यहाँ पे u ऑफ टी एक्स टर्म है, सो u ऑफ टी जैसे ही है, ठीक है, u ऑफ टी दैट मीन्स 0 to infinite. So in which direction the signal will be lie? How will lie? In right hand side. Okay, so this is not a left hand side signal. First of all, you have to know very clearly what do you mean by right handed signal and what do you mean by left handed signal. ओके, सो अगर u ऑफ t है तो आंख बंद करके उसको राइट हैंड पकड़ लो, ठीक है. u ऑफ माइनस t है देन लेफ्ट हैंड. नाउ वी हैव टू फाइंड आउट द पोल्स. सो दिस इज e to the power minus 3t and e to the power minus 2t. This is the coefficient of u of t. So poles will be minus 3 and minus 2. So poles, no need to find out. Poles will be minus 3 and minus 2. Okay, अगर u ऑफ u e टू द पावर माइनस 40 रहता तो पोल विल बी माइनस 3 एंड माइनस 4, और e टू द पावर अगर यहाँ पे e टू द पावर 80 है देन पोल्स विल बी a. ठीक है, सो नाउ टेल मी among this which one is the maximum, minus 3 or minus 2? Which one is the maximum from minus 3 and minus 2? मैक्सिमम वैल्यू कौन सा है? माइनस 2. So, as per our properties of ROC, properties number 5, if properties number 4, if the x of t will be right-handed signal, then ROC will be the maximum real part of the poles. ठीक है, तो ये obviously minus 3 is the real part and minus 2 also the real part. So which one is the maximum? So ROC of x of t equal to maximum minus 3 and minus 2. So ROC is minus 2. ठीक है, सो हम लोग ऐसा नहीं लिखेंगे, इक्वल टू नहीं लिखेंगे, क्योंकि ROC is lie sorry ROC lies within minus 2. So you can write also, no, not to worry, ROC equal to minus 2. So minus 2 is the ROC. ठीक है, so that means now how I will define the ग्राफ दैट इज आरओसी, ये एक्स का ये रियल पार्ट का है, ये जे ओमेगा है, ठीक है, ये जे ओमेगा है। सो आरओसी इज द स्ट्रिप, ठीक है, तो ये होगा तुम्हारा -2, -2, एंड आरओसी यू विल लाई इन लाइक दिस, ठीक है, तो ये हो जाएगा आरओसी। ओके, सो 2 से लेफ्ट हैंड साइड मत लेना, ठीक है, 2 से तुम राइट हैंड, सिंस राइट हैंडेड सिग्नल है तो 2 से राइट हैंड की तरफ जाना, सो इट विल बी आरओसी। सो लैप्लास का तुम्हारा आरओसी प्लॉट करने के लिए नहीं देता, सो नो नीड टू वरी, यू जस्ट राइट दिस लाइन, ठीक है। सो नाउ, क्योंकि स्ट्रिप देखो, स्ट्रिप ये कंटिन्यूअस स्ट्रिप होगा जब तक तुम्हारा सिग्नल जाएगा, ठीक है। सो नाउ इट इज नॉट मैंडेट टू ड्रॉ द आरओसी डायग्राम in case of Laplace transform. You just have to find out the value of ROC, that is ROC equal to -2. Now I am taking another example and quickly you will answer by seeing the question. Okay, let it be x of t equal to e to the power -40 ut u to the power minus u of minus t plus e to the power 3t u of minus t. Then quick, tell me what is the ROC by seeing the equation. This is 3, huh? This is 3. Quick. What will be the ROC? Tell me.
-4.
-4. Good. So ROC is -4. Because e to the power at, where a is the pole, so यहाँ पे e to the power -40, that is pole equal to -4 and it is 3. So ROC will be the minimum 3 and -4. दोनों में से minimum है -4. Now another example, x of t equal to e to the power -3t u of minus t plus e to the power -40 u of minus t. So in this case, -3 and -4, and in this in between -3 and -4, which one is the minimum one?
-4.
Good. That is the -4. So ROC is -4. So to calculate the ROC in case of Laplace transform for x of t is much more easier than your Z transform. So that's why Laplace is the modified version. ठीक है, Laplace is the modified version. Z transform is the basic one. That is the basic transformation from your time domain to frequency domain, and Laplace is the modified version. ठीक है, so that's how you can find out the ROCs of any signals. So first of all you have to know about the poles, because poles ka concept I have already given you in the Z transform. Okay, so now I will move to the topic, that is properties. Like your Z transform, Laplace transform also have some has some properties. So first properties of Laplace transform, that is properties. First property is linearity. Linearity property. So as per your linearity property, if x1t is first signal and x2t is the second signal, okay, then this second signal, then as per your linearity property, Laplace transform of a x1t plus b x2t will be equal to Laplace transform of individual x of t, that is x1s plus b of x2s. Okay, so now This is the linearity property of Laplace transform. ठीक है? Now we will prove it. That is, suppose x or x1t, a is the parameters coefficient, a x1t, x2t, b is the coefficient, x2t. Now, in both cases, we have to give Laplace transform. Laplace transform, and it will give you x1s and b x2s. Now we have to prove the linearity property. एक मिनट रुको. Just a minute. Okay. Okay. So now we have to prove this. So first of all, I am taking the individual signals and combine it and then Laplace. ये हो गया फर्स्ट कंडीशन. सेकेंड कंडीशन क्या है? x1t, इसको हम is a coefficient, x1t, x2t, b is the coefficient, bx2t. Now we have to add it. Now it will become ax1t plus bx2t. Now I have to give the Laplace transform, and whatever it will give in the form of Laplace transform of ax1t plus bx2t. Now we have to equate these two conditions. 1 equal to 2. ठीक है? And यहाँ पे क्या होगा? यहाँ पे एक स्टेप छूटा है. That is this one. ax1s plus bx2s. Okay. Now we have to prove. एक मिनट रुको. Just so now we have to prove condition 1 equal to condition 2. So first pick up the condition 1 where we don't have to do the lots of calculation, but in case of condition 2 we have to do the calculation of this. So we will pick up this condition. So condition number 2 we will pick up. So Laplace transform of ax1t plus bx2t. See what it will be given. That is 0 to infinite a x1t plus b x2t into e to the power minus st dt. This is the Laplace transform. E to the power st dt will be multiplied and then integrated with respect to d of t. Now we have to separate this. That is a 0 to infinite x1t e to the power minus st dt plus 0 to infinite b x2t minus st dt. So see, in this case, this part is x1s and this part is x2s. That is the signal multiplied with e to the power minus st and it will be integrated over dt. So that will ax1s plus b x2s. So that is equal to a log a1xt plus, sorry, this is not a1, b x2. So x1. So this is your proof of linearity properties of Laplace transform. Now move to the next property. Okay, and before going to the next property, how which kind of problem will be given from this type of property, because Laplace transform is very much important. In previous next semester, whenever you will get the digital signal processing as your subject course curriculum, then you will see that Laplace transform is very much important to find out the Z transform as well as Fourier transform. Okay, so I have to know what kind of problems will be given from Laplace transform on the basis of the linearity property of Laplace transform. Okay, so let it be x of t equal to 2 e to the power minus 2t u of t plus 4 e to the power minus 4t u of t. These are the signals. Okay, so now I have divided the signal into two parts, that is x1t, x2t. Okay, so now find the Laplace transform of the signal. Okay, it is simply says that you have to find out the Laplace transform of the signal. Now what I have to do, that is this is nothing but this part, x1t, x2t, x1t, x2t, and this is a and b, a and b. So I can say L of x of t is equal to individual Laplace transform. Okay, individual Laplace transform, that is L of 2 e to the power minus 2t ut plus L of 4 e to the power minus 4t ut. I can write it from this equation, from this property, from this property. Okay, so now I have to find out this. So I can find out the Laplace transform of this, that is 2 बाहर आ जाएगा and it will become e to the power minus 2t ut plus, sorry, 4 Laplace transform of e to the power minus 4t ut. So I have to now find out the Laplace transform of e to the power minus 2t ut. So e to the power minus 2t ut. What will be the signal? So you can simply integrate it with respect to 0 to with respect to d of t. Else there is a table, as I told you, to find out the Laplace transform. And the table in the page of your Ramesh Babu. Just a minute. I have to find out the table. Table is in the page, that is 7.38 from Laplace transform table, that is 7.38 पेज नंबर 7.38। हाँ, और ये रिमेंबर, ये चीज तुम एग्जाम हॉल में मत लिखना कि सर कराए थे तो फ्रॉम लैपलास ट्रांसफॉर्म टेबल थे सर, पेज नंबर 7.38 हम लोग यहाँ पे पहुंच गए। ठीक है, जस्ट यहाँ पे मैं टेबल का रेफरेंस इसीलिए लिख रहा हूँ कि तुम लोग जब पढ़ोगे तो ये टेबल पेज नंबर 7.38 में है। एंड यहाँ पे है तुम्हारा e टू द पावर माइनस ए टी, इसका लैपलास ट्रांसफॉर्म होगा 1 by s plus a। ठीक है, and in another way you can find out the Laplace transform of this, like 0 to infinite e to the power minus 2t e to the power minus, yeah, यहाँ पे है e to the power minus st dt. Now, what will be the term? 0 to infinite e to the power minus s plus 2. I can write t dt. Okay. So now you have to find out the equation integration of e to the power minus s plus 2 t. So what will be the integration of e to the power minus s plus 2 t dt? क्या होगा? क्या होगा? टेल मी. What will be the value of Laplace transform of this? Am I audible? What will be the value? Calculate it.
by s plus
What will
2.
be the value? Calculate it. हाँ बोलो.
Sir, 1 by s plus 2.
Right. गुड. आया. तो ये टेबल यहीं से डिराइव हो रहा है. ठीक है. एग्जाम में कभी ये चीज मत लिखना. डू नॉट राइट दिस अगेन. आई एम रिक्वेस्टिंग यू नॉट टू राइट दिस कि यह क्वेश्चन आया फिर तुम लिख दिया फ्रॉम लैपलास ट्रांसफॉर्म टेबल दैट इज पेज नंबर 7.38. कभी मत लिखना. नॉट इन एग्जाम. ठीक है. जस्ट फॉर योर रेफरेंस. ठीक है. एंड एक्चुअल जो कैलकुलेशन यहां से करना. ठीक है. ये कैलकुलेशन करना. सो नाउ यहाँ पे s प्लस टू ई टू दावर तुम्हारा 2 - 2t. सो व्हाट विल द वैल्यू ऑफ e टू दावर -40 लाइक dt 0 टू इंफिनिट. सो इसका वैल्यू भी s प्लस टू दैट इज e का कोफिशिएंट 2 है -2 है. सो s प्लस 2 होगा. तो यहाँ पे e का कोफिशिएंट क्या है? -4. तो यहाँ पे होगा 1/s+4. ओके. सो नाउ if we will put this value e to the power -40 dt integrated over 0 to infinity के बदले इसका वैल्यू पुट करेंगे और e to 0 to infinity e to the power -2t dt इसके बदले हम इसका वैल्यू पुट करेंगे. सो नाउ दिस इज द न्यू वैल्यू दैट इज your LXS equal to 2 into 1 by S plus 2 plus 4 into 1 by S plus 4. Okay, so overall total Laplace transform will be like this. X of S equal to 2 by S plus 2 plus 4 by S plus 4. This will be the Laplace transform of x of t. ठीक है. नाउ अगर मुझे लिनियरिटी पता नहीं होता तो क्या दिक्कत होता? आई हैव टू टेक द होल इंटीग्रेशन ओवर दिस. ठीक है. ये इसका टोटल इंटीग्रेशन मुझे निकालना पड़ता. टोटल इंटीग्रेशन फिर इसको डिवाइड करना पड़ता, फिर सेपरेट करना पड़ता. ये 2 स्टेप एक्स्ट्रा लगता. ठीक है. मुझे लिनियरिटी प्रॉपर्टी पता है इसलिए मैं क्या करूंगा पार्ट बाय पार्ट इसको x1t ले लूंगा, x को x2 ले लूंगा और नाउ आई हैव टू राइट द लिनियरिटी प्रॉपर्टी. देन आई विल कैलकुलेट दिस वैल्यू. ओके. सो नाउ नेक्स्ट प्रॉपर्टी इज property number 2. Next property indicates transform of derivatives. transform of derivatives. ट्रांसफॉर्म ऑफ डेरिवेटिव्स क्या बोल रहा है? इफ Laplace transform of x of t will be denoted by x of s, then L of d dt of x of t equal to s xs minus x of 0, that is negative part. ठीक है, ये तुम लोगों का डेरिवेशन है नहीं, ये एकदम डीएसपी में है, सो यहाँ से ये जान लो, ये स्टेप शॉर्ट क्वेश्चन में आता है, एमसीक्यू में आता है। ठीक है, नाउ दिस वन, व्हाट इज दिस वन? दिस वन इज नथिंग बट द नेगेटिव एक्सिस वैल्यू ऑफ एक्स ऑफ टी व्हेन टी इक्वल टू 0। ठीक है, सो ये है एक्स ऑफ 0 नेगेटिव पोर्शन। सो अगर हम इसको देखेंगे, ठीक है, यहाँ से तुम लोगों का न्यूमेरिकल आता नहीं है, जस्ट यू हैव टू नो द प्रॉपर्टी, दैट इज एक्स ऑफ 0 नेगेटिव टर्मिनल में कितना आता है वैल्यू एक्स ऑफ 0 का। ठीक है, नाउ like this your integration property, this is not in your syllabus as well as in your uh, detail part. I have just to write it because you are going to study Laplace transform of integrals, ये भी तुम लोगों का उतना है नहीं। ठीक है, यहाँ पे क्या लिख रहा है? if Laplace transform of integration over minus infinity to x of tau d tau equal to x of s by s plus minus infinity to plus infinity x of tau d tau by s। ठीक है, ये प्रॉपर्टी सिर्फ जान लो कि ये रहता है, कभी कभी शॉर्ट क्वेश्चन में आता है, बट दिस इज नॉट इन योर प्रॉपर्टी। whenever you are going to study in higher education like after btech, where if you are going to do the mtech part, and there is a topic that is advanced dsp, in this advanced dsp your transform of derivatives as well as transform of integral will be there। ठीक है, तुम लोग का बीटेक में कहीं पे कुछ क्वेश्चन यहाँ से नहीं आता है, जो क्वेश्चन आता है मेनली आता है तुम्हारा लिनियरिटी प्रॉपर्टी, और एक प्रॉपर्टी है दैट इज स्केलिंग प्रॉपर्टी। स्केलिंग प्रॉपर्टी 2 मिनट्स है, 2 मिनट्स में इफ a Laplace transform of xt is denoted by x of s, then ये चीज याद रख लेना। ठीक है, then L of a, सॉरी स्केलिंग हो रहा है तो ये नहीं होगा, x a t इक्वल टू 1/mod a x of s by a, ये याद रखना। ठीक है, नाउ दिस इज द स्केलिंग प्रॉपर्टी कि अगर तुम्हारा t में स्केल हो रहा है a में, तो इसका लैपलास ट्रांसफॉर्म होगा 1/a। ठीक है, 1/a x ऑफ s बाई a। सो इसके रिलेटेड तुम लोगों का प्रॉब्लम क्या क्या आता है, प्रॉब्लम एग्जांपल। ठीक है, प्रॉब्लम कैसे आता है, दैट इज गिवन x of t equal to e to the power minus t ut, find find Laplace transform of e to the power minus 3, sorry, find inverse Laplace transform of e to the power minus 3s x of 2s। ठीक है, e to the power minus 3s x of 2s। So now using this scaling property I can find out inverse Laplace transform. Inverse Laplace transform. Now in next class we will see what is inverse Laplace transform and how we will find out the inverse Laplace transform from your scaling property. Okay, so today up to this, and next I think you have another class after this, so I will not wasting too much I will not waste too much time. So now I am going to conclude the class. Okay, thank you all.